And so, yeah, feel free to come off mute and um, ask questions throughout the talk or put them in the chat. I may not always see the chat. The WebEx window's on a different screen. Uh, so my name's Ryan Richard. I'm organizing these virtual workshops on multi-project CI/CD. I'm a scientist at Ames National Lab, and I'm doing this as part of the BSS, BSSW Fellowship, which is the Better Scientific Software Fellowship. If you're not familiar with it, that's run by an organization whose website is bssw.io. Um, there's a lot of useful resources there, and these workshops are ultimately putting together resources so that I can put additional resources on the bssw.io website related to multi-project CI/CD. So that is my slide. There we go. So a lot of this work that I'm going to talk about was motivated by my role as the lead developer of NWChemX. I'll talk a little bit about what NWChemX is, but for the purposes of this talk, it's the architecture that's more important than what it actually does. So we're a very small team at the moment, about 5 or 6 of us. And so we were looking for ways to make our CI/CD more efficient in terms of reducing the amount of maintenance we have to do on it. Um, there was plenty of work out there for what I'll call single project CI/CD, but that was very limited. But the very limited resources for multi-project. So I'm not really going to go into best practices for single project CI/CD. This is really focused on how do you scale it across projects. And as I mentioned, I was awarded the 2024 BSSW Fellowship for this work, and that's what I'm going to be talking about. So very high level, what is NWChemX? NWChemX is a computational chemistry software designed to simulate chemistry. What matters for the purposes of this talk is we decided to write it as a series of plugins. So we have essentially a software developer kit, which in this graph is represented by the box labeled SIMD. That's the common library that everybody uses when they go to write their plugin, and then everybody writes a plugin based off that, and that their plugin lives in its own library. Typically, it's in its own GitHub repo. There's nothing restricting it to being on GitHub. It could be on GitLab or hosted locally. But the important point here is every plugin ends up being its own Git repository. And the reason behind this is we wanted to have the plugins be largely standalone reusable libraries, help integrate them into other software in the ecosystem besides just NWChemX. And I think I've heard from a number of people, this is a sort of a paradigm that's appearing in other areas of science. There's a lot more focus on modular software. So I suspect there are other people having these sorts of problems, and that's what these workshops were uh, really designed at getting at, is how do we manage the CI/CD for huge ecosystems of related libraries? So why did we want a modular ecosystem? So same reasons you probably heard about why modularity is good. We want to encapsulate. We have encapsulation and separation of concerns. It makes the development of a complex software system easier. I mentioned the reuse. And we also like it because it helps us with our rapid prototyping. You can this is one of the reasons why a lot of people like Python. There's a lot of Python modules out there. You can sort of pick and choose the ones you want, and that gives you an excellent starting spot for writing your scientific software. Um, the other thing we like about it in scientific software is it helps the contributions be better attributed. So when you, in particular in computational chemistry, we had this long history of these monolithic packages. You'll have 4,000 authors, 4,000 is an exaggeration. Easily a couple hundred though. And so your work gets lost in the author list. But with small individual reusable modules, it's easier to get attributed. So the problem we started to run into real quickly is there's a lot of infrastructure and utilities to support these repos, and that ends up looking very similar in every one of these repos. So each one of the repos has its own build system. The NWKMX is a C plus is largely C++. It has some Python, and so you're going to end up having a lot of CMake files that get duplicated across repos. Uh, a lot of formatting for the C++, etc. Furthermore, these tend to be a lot of these plugins are developed by similar groups of people, and so we have this same sort of formatting standards because they are the same people. You have a tendency to format your code the same way, regardless of which repo it's in. Uh, so we have similar formatting, we have similar configurations for the documentation. Uh, and so being software engineers, or research software engineers, I should say, we wanted to sort of streamline this and obey the DRY principle. If you're not familiar with DRY, it stands for don't repeat yourself. It's this idea that everything should have a single source of truth. This can be challenging when we're talking about utilities. And by utilities, I mean basically anything that's not the main software product. So all the software designed to support the software. That's because a lot of times this is developed more ad hoc. You'll have sort of one-off Python scripts or something that'll maybe parse your file and build your documentation or something. Um, the scripts tend to be boilerplate heavy. It sometimes can be hard to remove or factor out that boilerplate. And at least within computational chemistry, we also have to overcome this long-standing history of this is just how it's been done. We copy paste from one repo to another and tweak it. And so there's a lot of people that haven't even been thinking about how can we apply dry to the utilities and infrastructure supporting our software. At least again within computational chemistry. And I'm hoping to hear after the talk from other people about their experiences in their domains. So just to make sure we're all on the same page, probably should have had this sooner. What is CI/CD? So CI/CD stands for continuous integration, continuous deployment. Roughly speaking, it sort of follows the steps shown in the diagram. If you're familiar with GitHub Actions, GitHub Actions is a common work for implementing CI/CD. There's also Travis CI, Jenkins. GitLab has its own thing. I forget what it's called. I'm not much of a GitLab person. The main idea is we want to automate the building, testing, etc. of the software. And we can do that using the online resources provided by Travis CI, Jenkins, GitHub, etc. As I mentioned, the purpose of this workshop is really to focus on reusing CI/CD across projects. A lot of people I've talked to, they will say that, CI/CD is project specific. And while I think that's true when you're developing a single project, when you start developing plugins or modules and they're all targeting the same framework, there sort of ends up being the reality is you undermine that assumption. You end up reusing a lot of infrastructure from plugin to plugin, module to module. And again, we want to make sure we have a single source of truth, because if that framework changes, for example, how we have to build, you don't want to go through 400 plugins and change the build system or something like that. And so I founded the multi-project DevOps GitHub organization. Uh, if you Google multi-project DevOps GitHub, it should be the first hit. And the purpose of this organization is really to explore how to maintain multi-project ecosystems. The name DevOps is a little bit aspirational. Right now, it's really just focused on multi-project CI/CD. So we went through several attempts in trying to figure out what's the best practices for multi-project CI/CD. So we started with what everybody told us to do, which was copy, paste, and tweak. It was very tedious. We very often would run into problems where we forgot to include, say, a flag for the C compiler, and you now have to update 30 repos because you forgot that flag. So we very quickly wanted to move on from that. We tried Git submodules and subtrees. If you've ever tried this before in your own ecosystem, maybe it's worked for you, but the vast majority of people I talk to say it's very confusing, it's hard to do, and error prone. Yeah, it requires a lot of developer discipline if you're not familiar with it. You have to remember to always pull the submodules, etc. Ultimately, we moved on from that because our developers were not happy with that. So GitHub had some actions that existed. They were for auto synchronizing. So you would essentially put the files in a centralized repository. So we'd have like one CMake list.txt that's sort of templated. You would have to go through and change the names of the libraries, etc. But it sort of had the rough structure. And then you would use this action to automatically synchronize that file across all the repos. Um, so this was you can think of this as automating the copy paste. It was better because it was one source of truth. What we found was the triggering was a little touchy. So sometimes the triggering wouldn't occur, and so the changes wouldn't actually propagate. Other times it would be constantly rewriting the files and could even get into loops where it saw that a file was changed, and so then it would change another file, but because that file changed, it went back. Thankfully, GitHub stops those kinds of loops after a couple iterations, but yeah, that was troublesome. We moved on to Docker files after that and started we would version control the Docker files. Um, that was okay. It ultimately led a lot of the repetition to just be in the Docker file, so it didn't completely solve the problem. Um, we looked into making actions for GitHub Actions. So unfortunately, GitHub Actions is both the name of the CI/CD framework and also a name of the component in the framework. So that's a little confusing. And so right here, what I'm talking about is writing a component for that framework. So essentially, you would write a little application that knows how to, say, build a code using our build system, given a couple parameters. So that worked. That was a very nice solution other than writing GitHub Actions is very heavy-handed. There's a lot of development that goes into writing a GitHub Actions, and this just felt like overkill for um, trying to just modularize the CI/CD. Thankfully, about the time we got to this point, GitHub apparently had also realized there was a problem, and they introduced reusable workflows and composite actions. Uh, when we started down this endeavor, GitHub Actions actually did not have reusable workflows and composite actions, which is why we didn't just jump to this solution. I think that only came out in maybe the last 2 to 3 years, something like that. There is a similar feature in GitLab, and ultimately, reusable workflows, composite actions is what we decided with, and that's really what a lot of the best practices I'm going to talk about are based off of. And that's an example of a composite action there. Um, yeah. So there's a little bit of background. So what makes multi-project CI/CD different than CI/CD? So again, it's sort of this idea of reuse. So on the left side of the figure, you see that there's sort of two pipelines. There's one for package one for package two. They have sort of some similar components in there that they, for example, both do a configure, build, and install stage, but ultimately they're maintained as two separate scripts. In the multi-project view, we view it as a reusable pipeline that we feed different packages through. So it's a fundamentally different way of thinking about it, trying to treat the pipeline as a single source of truth. Um, one of the big differences in our experience between multi-project and single project CI/CD is the fact that since you now have a bunch of projects relying on a single pipeline, if that pipeline breaks, you don't just break the one repo that the pipeline's associated with, you break the ecosystem that that pipeline's associated with. There's also security concerns. We're an open source package. We're not as concerned with security as a lot of other packages are. That's a problem I don't know the answer to, and I'm just going to mention it does exist. Anytime you're sharing software across an ecosystem, there are security concerns, but that's not something we attempted to solve here. So after a bunch of trial and error and looking on the internet and seeing what other people have done, we sort of came up with these four best practices for multi-project CI/CD. So the first one is dry. Don't repeat yourself. Just like all other software, you really should be striving to follow good software engineering principles and not repeating yourself, i.e., having a single source of truth, is one of the key principles. You also should be treating your infrastructure as code. So if you're not familiar with this concept, it's the idea that you should be using configuration files or scripts to set up the environment rather than GUIs. This allows you to version control your steps and ensure that you're getting a consistent development environment in the CI/CD pipelines. There's this other idea of treat code as code. So I made up this term. I don't think anyone else has used this. But when I talked to software engineers, they didn't have a catchy little terminology for this best practice. They said this is really sort of it's obvious to them that you should be doing this. But in my experience, this is not obvious in the scientific computing circles. And so what does code as code mean? It means that you need to treat all of the code using best practices, not just the main software that is your package. So in our case of NWChemX, for example, we were of course using best practices for the main source code of NWChemX, but what code as code refers to is you need to also be using the best practices for all your scripts that support it, your utilities, those sorts of things. And I alluded to it on the last slide. The other main multi best practice here is testing. In my experience, a lot of people don't have formal tests in place for CI/CD. Often it's you write a CI/CD workflow and you trigger it, see if it works. If it did, great. If it didn't, then you go back and you iterate until it works. Testing becomes a lot more important. Again, you're going to have an ecosystem depending on these things. You can't just be pushing changes to the workflows and hope that they work because you may end up bricking an entire ecosystem. What's good about this is since we've factored out the CI/CD into one place, and I'll go into that on the next slide, it's easier to test it because it's only in one repo. We don't have to worry about testing multiple repos simultaneously. So as far as GitHub specific best practices, which is what I've really been focusing on, you sort of have these two things. You have composite actions, which you can think of a composite action as reusing a task. What a task constitutes is really up to the developer. You could have a task be as something as fine-grained as, say, just running a configuration script for like a C++ build, or it could be the entire configure, build, install step, really up to you. And the other thing you have are reusable workflows, which reusable workflows are sort of drivers wrapped around the actions. So it's a series of actions run together, and you're reusing that series of commands. It's suggested that you use one workflow per trigger condition. So you have a workflow for on pull requests. So when someone makes a pull request, you have one workflow for when someone pushes to your main or master branch, etc. Don't try to reuse the workflows across push across trigger conditions. More often than not, there's little differences. It's better to modularize the internals of the workflow than to try and put a bunch of if-else logic through the workflow to make it so that it works under both trigger conditions. It's recommended you consider dedicated repositories for your composite actions. Uh, this is because GitHub tracks versioning on a per repo basis. In particular, you can, or an alternative is to store them in the .github repo and just be very meticulous with your commits. What I mean by this is if you only modify one composite action per commit, then your get versions will still essentially map to a single action. The problem is if you change multiple actions in one commit, then there's not really a good way to distinguish whether you want to use, say, version one of action one and version two of action two, since they both are tied to the same commit. Um, Reusable workflows are meant to be used across an organization usually, so they are recommended that you put them in a single .github repo. Composite actions are usually thought of as being more general, more useful outside the organization. That's why they were suggested as their own repos. If you have a lot of them, though, yeah, there can be a trade-off to that. And you should always be referring to the actions reusable workflows by version. Uh, so multi, so those best practices are a summary of the resources I've put together so far and the results of previous workshops, etc. You can find the work on my endeavor into trying to figure out best practices for this on the multi-project DevOps website. There's some tutorials and resources there. There's the best practices, and more importantly, if you really want to, well, I don't know if it's more important, but there's also the explanations for how we came to those best practices. So most of them didn't just come out of thin air. There's actually logic behind why that's there. And I'll also do a shout out to one of my colleagues. He put together a nice YouTube video explaining how we came to our sort of multi-project DevOps uh, or multi-project CI/CD workflow. And that video, the link is available through the multi-project website. So with that, sort of going to summarize here. So modularity, in my opinion, really complicates the CI/CD workflows. Um, if you want to apply dry, don't repeat yourself to CI/CD, then there's additional consideration. Um, GitHub has made it a lot easier than when I started this endeavor. So when I started this endeavor, it wasn't as easy as it is now, thanks to GitHub's reusable workflows and composite actions. Reusable workflows are, again, sort of a driver, and composite actions are really geared at reusable tasks. And I'm looking for collaborators to really flesh out more resources, maybe come up with some recipes for examples of composite actions or those kinds of things for the website. Or if somebody was interested in, for example, repeating these processes for GitLab so we could reach a better group of the scientific, or a larger group of the scientific software community. And with that, acknowledge the people who funded this and helped work, and I'm happy to answer any questions you might have.